So today we're going to talk about dividing monomials, and we'll still be using some of our multiply monomial rules, hopefully. But if you think about it, if we have x to the fifth divided by x to the second, if you write out what that means, that's 5x's, 2x's. And what happens? What is x divided by x? 1, and x divided by x, 1. And what are you left with? X to the third. Sorry, I can't really read my exponents here. And this was a 2. So what is the shortcut? Yes, it is that you subtract the exponents. So that's kind of the shortcut. Same thing if we had a power raised to a power. Everything, or a quantity raised to a power, everything in there is that power. Same thing if we have a quotient. Both of them are raised to that power. Think about this for a minute. X to the fourth divided by x to the fourth. Well, again, if we write it out, it's 4 of these and 4 of these. And cancel, 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 cancel. So what are you left with? 1. What is 4 minus 4? 0. So that's kind of where this rule comes from right here. Anything to the 0 power is equal to 1. And what if we have x to the second over x to the fourth? Well, x times x, 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 cancel, cancel, and you're left with 1 over x to the second. And what is 2 minus 4? X to the negative 2. So again, that is where this rule comes from. Anything with a negative exponent is 1 over that with a positive exponent. So it doesn't always make sense, but if you think of it in this way, I think it will make sense. So a negative exponent is not a negative number, it is a fraction. So that's important to remember. So you'll probably have to be referring back to these rules. I don't think we're going to get into too many of this rule today, but I think we might. I can't even remember for sure. So we'll see. So let's do some examples using these ideas. So when a directions say simplify, it's only simplified if it has a positive exponent, so we don't leave any negative exponents in our final answer. So here again, it's just dividing a monomial. Remember, the bases have to be the same, so the exponent on the A would be 5 minus 1 would be 4, and the exponent on the B would be 8 minus 3 would be 5. And you're done. When you're doing numbers, they're regular numbers, so 6 divided by 2 would be 3. X to the 7 minus 6 is 1, so you do not need to write that exponent. I usually don't write it. And 12 minus 3 is 9, so it would be 3x to the 9th. Okay, and this one, again, x to the third divided by x to the first would be x to the second. Y to the 0 is equal to 1, so x to the second times 1 is just x to the second. Here we're using the idea of making sure each one is to the third power. So this is really 2 to the third over 5 to the third, and then you need to do the math. I'm in trouble writing my 3's today. 2 to the third, 2 times 2 is 4, times 2 is 8. 5 to the third, 5 times 5 is 25, times 5 would be 125. So that's what we would write for that one. Alright, so this kind of uses what we were doing here with monomials. 2p squared all to the fourth power, remember, would be 2 to the fourth, which would be 16 p to the eighth over 3 to the fourth. 3 times 3 is 9, and 3 times 3 again is 9, that's 81. So 16 p to the eighth over 81. Now here we do have to use that idea about no negative exponents. So I'm going to try to do it without writing out all the steps. But remember, like b to the negative 3, what did that mean? It meant 1 over b to the third. So the b to the third is going to come down here. So when it has a negative exponent in the numerator, it moves to the bottom and becomes positive. c to the second is going to stay down here. Well, the reverse happens here. The d to the negative third is going to go to the top then and become positive. So that's all we would need on that. So there's not any really simplifying you can do except for fixing the exponents and writing them with positive exponents. Alright, on this one, again, let's take care of our numbers. We got a negative 3 and a 21, so if we divide them both by 3, we're going to get 7, and it still has a negative sign on the top. So I'm going to keep a negative on the top and just put my 7 down here. Negative 4 minus 2 is going to be a to the, again, it becomes plus negative, would be negative 6. And I'm not going to do any moving. I'm just going to write my exponents down first, and then I'll do the moving once I get the simplifying part done. b to the seventh would be b to the 0. You don't really need to write that down if you don't want, but since I'm doing another step, I might as well write it down because it is equal to 1, remember. And then I don't have any c's on top, so my c to the negative 5 would just stay here. So now I need to simplify it without having negative exponents. So don't forget, I still have a negative sign here somewhere. The a to the 6th is going to move to the bottom. The b to the 0 is going to be 1, so if I don't have anything up here, I'll put a 1, but I am going to move my c to the 5th up here. And then that would be my answer, negative c to the 5th over 7a to the 6th. And remember, the negative sign can go anywhere, although usually we don't leave it in the denominator. And that is it for